Okay, now in this problem we have an enamine and we want to hydrolyze it back to the carbonyl compound and give what is the amine that we use. And now we're going to focus here. This is the carbon that is going to become the carbonyl here, and it is this carbon. I mean, of course, once you get used to do this is going to be cyclopentanone and dimethylamine, but we're going to be doing the mechanism. In the mechanism, again, we're going to be finding a lot of proton transfer steps. And so this time, because I'm going to be moving those electrons over here and then catching up one proton. When I do that, I'm going to form the following. Here, I no longer need to draw the H, but I'm going to have this N to metal group. Now, this is formal positive. These lines, remember, are metal groups. Now, this, as we explained before, this carbon is now more electrophilic, and we will have the nucleophilic attack by water. So in the next step, this is water attacking over here. And now, what we're forming, let's do it. We're going to have the carbon that I have highlighted, which is going to become the carbonyl. Now I have the water. Here it is, positive, and then I'm going to have, since I moved those over, I'm going to have metal, that. And now I'm going to do one proton transfer step, removing this, and my product is going to be an intermediate that we find commonly in here, which is the carbenolamine. Carbenolamine. Okay, and here we are. Now, we need another proton transfer step because, as we know, this is a bad leaving group. So we're going to do a proton transfer step. So I'm going to draw now over here. These two hydronium. A hydrolysis of the enamine, again, under acidic condition, of course. So we're going to be doing this to get that, and our electrons go in with the oxygen. And now I have my OH for the carbenolamine, and now I'm going to have metal, and one hydrogen that I just added, formal positive. So next step would be forming the carbonyl. So I'm going to do double bond here. And now this is a good leaving group, and this will depart to form the following. Now I have this had departed, so minus what had departed is dimethylamine. So I'm going to do metal 2 times NH. So that is my amine, that is leaving. And I have protonated cyclopentanone. So the last step is simply deprotonated that. So I'm going to have, say, water doing the proton transfer. And my initial molecule was cyclopentanone. And to get this, I had to react dimethylamine, a secondary amine, and this is pH between 4 and 5. So this is the final step. So from here to here is enamine formation, and this is backwards. So this is where you started with. So you hydrolyze the enamine back to the carbonyl compound in the primary, the secondary amine.